Hello everyone, I'm Dr. Manju Gupta, Department of Chemistry, St. Aloysius Autonomous College, Jabalpur. Today we are going to discuss intensity and position of some more functional groups in IR spectroscopy. First we are discussing IR spectrum of carbonyl compounds. In organic chemistry, there are number of compounds are present, and in these compounds, most of the compounds, maximum portion of the compounds contain C double bond O group, that is carbonyl group. And carbonyl group is considered as a perfect functional group for IR detection. Why it is known or considered as the perfect functional group? Because of intense stretching vibrational peak. Intense stretching vibration peak observed because of a large dipole moment produced by the polar carbon-oxygen double bond. This bond shows absorption in between 1600 to 1850 centimeter inverse, which is the unique part of IR spectrum. So this region is also known as carbonyl stretching region. Several carbonyl compounds may be possible. Generally, if we talk about carbonyl compound, then we have an idea about aldehyde or ketone, R2C double bond O or RCH. But it may be RCOCl, acid halide, RC double bond OOR ester, aldehyde, ketone, RCOOH carboxylic acid, RCONH2 acid amide, or acid anhydride. 1, 2, 3, 4, 5, 6, 7. 7 class of organic compounds have carbonyl group. When we calculate the value of C double bond O stretching vibrational frequency according to the Hooke's law, the value comes to be 1715 centimeter inverse, which is of ketone, and this value is considered as the base value. But you can see for different type of carbonyl compound, this base value shows some deviation. For example, in case of acid chloride, RCOCl, carbonyl group shows absorption at 1800 centimeter inverse. Esters, RCOOR, shows absorption at 1735 centimeter inverse. Aldehyde shows absorption at 1725 centimeter inverse. The base value we can consider as of ketone, and it shows absorption at 1715 centimeter inverse. Carboxylic acid, RCOOH, it shows absorption at 1710 centimeter inverse, and acid amide shows absorption at 1690 centimeter inverse. Whereas for acid anhydride, RCO whole twice O, it produced two bands, one at 1810 and another near about 1760 centimeter inverse. So you can see here there is a change in the values according to the base value. Some carbonyl groups shows absorption above the base value 1715, and some shows absorption below the base value 1715 centimeter inverse, like in the case of acid and amides. What is the reason of the deviation of the carbonyl absorption as compared to the base value? This deviation depends on the nature of the group attached to the carbonyl group. So first we discuss effect of electron donating group on carbonyl frequency. Effect of electron donating group, these groups may be methyl, ethyl or NH2. These groups are considered as electron donating group. When these groups are attached with the carbonyl group, they donate the electron towards the carbon, and carbon, since oxygen is more electronegative, so there is the flow of electron from carbon to oxygen. In this condition, the double bond character of C double bond O will increase, will decrease. So because oxygen withdraw the electron in this way, the double bond character of carbon oxygen bond decreases. When the double bond character decreases, the value of force constant decreases, and when the value of force constant decreases, the value of vibrational frequency decreases. Or we can say all the compounds which show plus M effect. Plus M effect, positive mesomeric effect by operating positive mesomeric effect, they will decrease the electron density in between the carbon oxygen bond and increase the electron density on oxygen. So the value of vibrational frequency decreases. When electron withdrawing groups are attached to the carbonyl group, these electron withdrawing group attract the electrons from the oxygen and increase the electron density in between carbon and oxygen. When the electron density when carbon and oxygen in between carbon and oxygen increases, the double bond character of carbonyl group increases. When double bond character increases, the value of force constant increases. Since force constant is directly proportional to vibrational frequency, the value of vibrational frequency will increase. That's why acid chloride shows absorption near about 1800 centimeter inverse because of the electron withdrawing nature of chlorine. Similarly, in case of acids, where carbonyl group is involved in the hydrogen bonding. Carbonyl group involved in the hydrogen bonding. Because of hydrogen bonding, this will decrease the value of force constant, increase the value of bond length, and it may weakens the carbon-oxygen bond. When the force constant of carbon-oxygen bond decreases, it shows absorption below 1700. Acid shows absorption below the base value. So when electron donating groups are attached, electron donating groups decreases the value of carbonyl frequency as compared to base value. Electron withdrawing groups increases the value of vibrational frequency, and if the molecule is involved in hydrogen bonding like in carboxylic acid, they again decreases the value of vibrational frequency because of weakening of carbon double bond oxygen bond. Several carbonyl compounds are present, but IR spectroscopy is the most important or most accurate method for the determination of carbonyl compound, type of carbonyl compound. If we go for the chemical test and only to distinguish aldehyde and ketone carbonyl group, we required several chemicals and it is time taking. But only with the IR spectroscopy, with the help of IR spectroscopy, we can conclude which carbonyl group, aldehyde, ketone, acid, amide, esters, anhydride, which carbonyl group is present in the molecule. The C double bond O bond is common in all the molecules, but other than this common bond, every type of carbonyl compound has other places to confirm the conclusion. What type of carbonyl compound is present? Aldehyde or ketone? Other than carbonyl group, there must some other peak will be present. What will be the peak? First, in case of aldehydes. In case of aldehydes, carbonyl C double bond O absorption occur at 1725 centimeter inverse. Other than this aldehydic CH bond, because of Fermi resonance. Because of Fermi resonance is the coupling of fundamental CH with the fundamental overtone. Sorry, with the overtone of CH vibration. CH, fundamental of CH stretching couples with the overtone of CH bending. Then it produces a doublet that is known as Fermi resonance. So first carbonyl peak in case of aldehyde observed at 1725 centimeter inverse, and because of Fermi resonance this CH aldehydic CH bond produce a doublet at 2850 and 2750 centimeter inverse, which is totally absent in any other type of carbonyl compound. So when in the molecule carbonyl group is present and at 28 and 2700 two small peaks are present, then it is confirmed it is aldehyde. In case of ketone, carbonyl is similar, C double bond O absorption present at 1710 centimeter inverse, and OH band shows absorption near about 3600 centimeter inverse. Since the acid molecules, all the carboxylic acid molecules are associated by hydrogen bonding and present as a dimer. Because of the association, this OH band is broader than the intermolecularly hydrogen bonded OH group. So a broad band from 2800 centimeter to 3600 centimeter is observed because of the acidic OH. Amide. In case of amide, C double bond O carbonyl is common, present at 1690 centimeter inverse. Other than carbonyl, two NH bands observed near 3300 or 3400 centimeter inverse. So carbonyl plus two bands at 3300 centimeter inverse, amide. Carbonyl plus broad band at 3500 centimeter inverse to 3000 centimeter inverse, it is acid. Carbonyl plus two small bands at 2800 to 2700 centimeter inverse, it is aldehyde. In case of esters, two carbon oxygen bonds are there. One is carbon double bond oxygen and another is carbon single bond oxygen. C double bond O carbonyl group shows absorption as 1735 centimeter inverse, whereas carbon single bond oxygen shows absorption at 1200 centimeter inverse. Now there are two carbon single bond oxygen. One carbon is of carbonyl group, that is sp2 hybridized, and another of sp3 hybridized carbon of alkyl group. So one CO stretching will be sp2 carbon CO and another will be sp3 carbon CO. These two bands observed at 1200 and 1000 centimeter inverse. Other than this, in case of ketone has only one characteristic peak, that is of C double bond O. In case of anhydrides, in anhydrides there are two carbonyl groups. We will see later. There are two carbonyl groups which may couple to each other and produce two peaks nearby 1800 centimeter inverse. So in this way, we can separate or we can conclude which carbonyl group is present in the molecule. These are the two spectrums of ketone and aldehyde. This is the spectrum of ketone. Two alkyl groups are attached with the carbonyl group. These two alkyl groups shows CH stretching below 3000. Carbonyl, since ketone shows the base value, in ketone the C double bond O stretching is observed at 1719 centimeter inverse. In aldehyde, it observed at 1730 centimeter inverse. How we distinguish between the carbonyl of ketone and carbonyl of aldehyde? Both the carbonyl groups frequencies are more or less same, shape is the same, but in case of aldehyde, these are the two peaks observed because of the Fermi resonance. One at 2717 and another at 2840. So with the carbonyl, when these two peaks are present, we can confirm that compound is 100% it is aldehyde, because Fermi resonance is the characteristic of aldehydes. Next, in case of esters. In case of esters, this is the carbonyl group. Carbonyl frequency observed at C double bond O, 1741 41 centimeter inverse, and two alkyl groups shows absorption below 3000, CH stretching. Two carbon oxygen stretching are there. One, this carbon is sp2 hybridized, sp2 carbon oxygen and sp3 carbon oxygen. As the percentage of S character increases, the value of vibrational frequency increases. So out of 1210 and 1064, 1064 carbon oxygen stretching because of sp3co. And at 1210, this is the carbon oxygen stretching in which carbon is sp2 hybridized. So in case of ester, other than carbonyl group, two peaks in the range of 1200 to 1050 centimeter inverse because of sp3co and sp2co bonds. Carboxylic acid. Very simple to diagnose the carboxylic acid. Carbonyl with a broad band from 2500 to 3500, near about 1000 centimeter inverse. From 25 to 3500 centimeter inverse, a broad band shows the presence of hydrogen bonding in the carbonyl compound that is only possible in the acids. In acids, two acid molecules are joined together, attached together, attracted together, bonded together by hydrogen bonding, and they exist as the dimer. Because of the dimer formation, the OH band is very broad in case of acid. It is the broadening of the band is greater as compared to the intermolecular hydrogen bonding in the alcohols. So when carbonyl is present at 1700 and broadband present near about 2500 to 3600 or 3300 centimeter inverse, the compound 100% we can see this as, we can say that the compound contain carboxylic acid group. By IR spectroscopy, we cannot conclude which molecule is present. Only we can conclude which functional group is present in the molecule. Next carbonyl is amide. In amide, other than carbonyl, two NH bands will be observed. So, because of NH2 electron donating effect, the vibrational frequency decreases. It observed at 1640 centimeter inverse, and two NH bands. Two NH bands produced nearby 3300 centimeter inverse. After amide, anhydrides. In anhydride, there are two carbonyl groups, one CO and another CO. Both the carbon oxygen bonds or both the carbonyl bonds are vibrating with the same frequency or absorb the same frequency, that are only separated by a single oxygen. So these two vibrations may couple with each other. This coupling is known as vibrational coupling. So because of vibrational coupling, these two carbonyl groups produce doublet. one at 8 and produced two peaks, one at 18 centimeter inverse, another at 17-15 centimeter inverse. So when carbonyl peak is observed at doublet 1700 at nearby 1700 centimeter inverse, the peak appears as doublet, then only the carbonyl group in the form of anhydride can be present. Last carbonyl compound is acid chloride. Chlorine is electron withdrawing. Because of electron withdrawing nature, it will increase the double bond character of carbon oxygen bond, and as the double bond character increases, the value of force constant increases, and as the value of force constant increases, the carbonyl absorption shifted towards the higher value. When the carbonyl absorption crosses the value of vibrational frequency or observed above 1800 centimeter inverse, 100% we can say it is acid chloride. Only in acid chloride the value of carbonyl group is higher than 1800, and these two are the CH stretching of alkyl group. So these was the spectrum of these are the spectrums of all the 7 classes of carbonyl groups. In case of ketone, only carbonyl group observed. In case of aldehyde, carbonyl plus Fermi resonance at 27 and 2800 centimeter inverse. In case of acid, carbonyl plus broadband at 25 to 3500 centimeter inverse. In case of amides, carbonyl plus 2 bonds at 3300 centimeter inverse. In case of esters, carbonyl at 1750 centimeter inverse and 2 bands because of carbon oxygen single bond, sp2 carbon CO and sp3 carbon CO near about 1200 centimeter inverse. And in acid chloride, when the carbonyl is shifted towards 1800. In case of anhydrides, when the carbonyl itself is appear as doublet. IR spectrum of nitro compounds. In case of nitro group, again there are 2 nitrogen oxygen bonds. These are in resonance with each other. 2 bands observed for nitro group, and O asymmetric stretch. It appears at higher wave vibrational frequency 1550 to 1475 centimeter inverse, and asymmetric stretch from 1360 to 1290 centimeter inverse. So in case of nitro compounds, 2 bands in the range of 1500 to 1200 of different intensity. In case of nitrile, nitrile is again a polar bond, C triple bond, and is a polar bond because of the high polarity and the high value of force constant for triple bond. The value of vibrational frequency shifted towards higher value, and C triple bond and bond shows absorption at 2248 or 2100 to 2080 centimeter inverse. Thank you.